Students, we move with the next topic, that is kinematics of rotational motion. What do you mean by kinematics? We have seen what is the rotational motion, and the chapter is dealing with the rotational motion only. But what is the kinematics? That is very important. Kinematics is the study of motion of a body without regard for the cause of motion. Here we don't consider any cause of motion. Cause of motion means generally what we consider as the force. So that is the kinematics, right? But in dynamics, we consider cause of motion also. That is what you call it as the force. Cause of motion, generally the force की हम बात करते हैं, ठीक है? तो यहाँ पर kinematics तो जब भी हम डिस्कस करते हैं बेटा, अगर आपको याद होगा kinematics, तो we have seen the equations of motion. V is equals to U plus AT. S is equals to UT plus half AT square. Next, we have seen V square minus U square is equals to 2AS. All these equations we have seen, but you are not going to get a single letter F, the force term F, in any of the equations. That means we don't consider in kinematics में हम consider ही नहीं करते हैं cause of motion. But if you go for dynamics, 100% we have to consider the cause of motion also in order to study the motion of the body. I hope it is clear. Now, under this heading, that is kinematics of rotational motion, what we are going to study? We are going to study like what is the angular velocity, what is the angular acceleration, and what is, I can say, the relationships that exist with this. I request all the students not to remember all the equations what I am giving you. Don't try to mug up better. इसको मैं जब relation जो बता रहा हूँ, that relation is very important. Just try to remember the relation, and accordingly you can write the equations and you can solve the problems also. So here, what I was saying here is, don't remember, don't try to mug up the equation. Just हमको remember क्या रखना है, trick or the logic what I am showing you. In like what are this? In linear motion, that is translatory motion, we speak about डिस्प्लेसमेंट, राइट? थोड़ा सा अच्छे से ध्यान दीजिए बेटे. यहाँ पे लीनियर मोशन में जब बॉडी मूव होती है एक जगह से दूसरी जगह पे, वी स्पीक अबाउट द वर्ड डिस्प्लेसमेंट. तो हम यहाँ पे जब रोटेशनल मोशन की बात आती है बेटा, तो हम डिस्प्लेसमेंट की ही बात नहीं करेंगे, हम बात करेंगे एंगुलर डिस्प्लेसमेंट. ट्राई टू अंडरस्टैंड. वहां पे जब इन द लीनियर मोशन और द ट्रांसलेटरी मोशन, when the particle is moving from the point A to the point B, we speak about the word displacement. S से हम डिनोट करते हैं. बट यहाँ पे हम किससे डिनोट करेंगे, एंड इसको हम क्या बोलेंगे? व्हेन द बॉडी रोटेट. तो आप डिस्प्लेसमेंट की तो बात नहीं कर सकते यहाँ पे, तो हम यहाँ पे बात करेंगे एंगुलर डिस्प्लेसमेंट, एंड वी डिनोट इट बाय थीटा. Now, suppose if a body is moving with certain velocity in translatory motion, in linear motion में जब मैं बात करूंगा, अगर बॉडी मूव हो रही है with certain velocity, तो वहां पे हम वर्ड यूज करेंगे velocity ही. लेकिन जब बॉडी जब रोटेट होती है ना बेटा, तो हम velocity की बात नहीं करते हैं. We have to speak about the term or the physical quantity, that is angular velocity. I repeat, angular velocity. वहां पे displacement, यहाँ पे angular displacement. वहां पे velocity, यहाँ पे angular velocity, and angular velocity we denote it by omega, that already we know. Next, suppose if I say one body on a straight road is moving with an acceleration a. So here the body is not moving along the linear motion, right? It's not moving along a straight road. It is rotating. तो मैं यहाँ पे क्या बोलूंगा? Body is rotating with an angular acceleration. बेटा just आपको word add करना है angular acceleration, and that angular acceleration we denoted by alpha. Alpha से हम denote करते हैं. So what I do, I am going to show here what are the equations we already used in kinematics for linear motion. Now how we can reframe that equations for the kinematics of rotational motion. The first one, pay attention. बेटा फर्स्ट इक्वेशन पता है आपको, दैट इज v इज इक्वल्स टू u प्लस at. द सेकेंड वन, s इज इक्वल्स टू ut प्लस हाफ at स्क्वायर. थर्ड वन, this is v square minus u square is equals to 2as. The fourth one we have, that is Sn is equal to u plus n minus half into a. And the fifth one, what I have given you, S is equals to u plus v by 2 into t. These are the equations of motion what we have already studied in kinematics. So let us frame these equations, or let us see what are the analogous equations for these equations, ठीक है, in rotational motion. This all I have written for translational motion. ये सारे equations translational के लिए. Now I am writing for rotational motion. What I said you students just now, displacement is replaced by angular displacement, velocity is replaced by angular velocity, acceleration is replaced by angular acceleration, and डोंट थिंक भाई टाइम है तो वहां पे एंगुलर टाइम होगा, नहीं होगा बेटा, टाइम इज टाइम ओनली, ठीक है. चलिए आइए, दिस इज v, it is the velocity. There we have to convert as the angular velocity, and we know angular velocity we denote it by omega. Omega से हम denote करेंगे. So we write this as omega. Because it is final, so I will write it as omega 2. That is equal to, what is this? This is also velocity, initial velocity. Therefore, I will write with omega 1, and plus this is acceleration. So I have to write angular acceleration, and this is the time t. So this is the first equation what I am getting in rotational motion. By if suppose students, if you just see this, it seems to be a new formula for you, and you people just what you do, इसको याद करने की कोशिश करते बेटे आप, नहीं, जरूरत नहीं है. जस्ट आपको टर्म्स पता होना चाहिए, what the terms we are using for linear motion and what the terms we are using for rotational motion. So this velocity I'm replacing by omega. It is final velocity, initial velocity. So this omega 2, omega 1. Acceleration, here it is angular acceleration, time as it is. Now let us move for this second equation. What is this S? S is the displacement. I want to convert that displacement as the angular displacement, and you know angular displacement we denote it by theta. So अब हम लिखते हैं बेटा यहाँ पे theta. This S is theta. Next, what is this U? U is the linear velocity that I can convert as the angular velocity. So that is initial velocity बेटा, तो हम just omega भी लिख सकते हैं. If you want to write omega 1, you can write omega 1 also. Either you can write omega or omega 1 also. So this is ut, that is omega 1t plus half. What is this? A is alpha, this is t square. Third one, pay attention. Third one, v square minus u square is equals to 2as. This is the linear velocity, linear acceleration, linear displacement. तो हम यहाँ क्या करेंगे इसको angular velocity, angular acceleration, angular displacement में convert करेंगे. करिए, देखिए, this is omega 2 square minus omega 1 square, that is equals to 2. What is this? A is alpha, and this is theta. Fourth one, this is the displacement in the nth second. So what I do, angular displacement in the nth second, that is equal to u plus n minus half. U is n minus half, and this is what you call it as a. A is acceleration, here angular acceleration we can consider. The fifth one, this is again the displacement. So let us convert this as the angular displacement, that is equal to u plus v by 2, that is omega 1 plus omega 2 by 2 into t. So just आप इसको नहीं देखेंगे, you need not to say this one बेटा, just you know this directly, you can write the equation and you can solve the particular problem. We are going to solve the problems also, no need to worry about that. One thing, there is a relationship between the linear velocity and the angular velocity, linear acceleration and the angular acceleration. So let us see what is that relation. So let us see first one. Note, the first one, relation between the linear velocity and the angular velocity, v is equals to, you know, r omega. V is equals to r omega, where v is the linear velocity, omega is the angular velocity. Now if I differentiate this equation, dv by dt, I am getting acceleration. ये साइड भी अगर हम differentiate करते हैं students, r is constant, that is the radius of the body is constant. Omega को अगर हम differentiate करते हैं, d omega by dt, that gives you the angular acceleration. The second note will be, this is acceleration. If I differentiate this, I'm going to get the angular acceleration. So in addition to this, you should know what are the relationship between the linear velocity, angular velocity, what is the relation between the linear acceleration and the angular acceleration. Hope you have understood how to write the equation for rotational motion from the equations of linear motion. Students, we have seen the relationship that exists between the linear motion as well as the rotational motion. And we have seen how to convert an equation from the linear motion to a equation for rotational motion. So let us see the problems on the first problem on the board for this is the angular velocity of a particle changes from 100 radians per second to 200 radians per second. That means the angular velocity omega 1 value is given here. Try to understand the equation. Omega 1 it is 100 radians per second, and omega 2 it is, we can see that is final 200 radians per second. In how much time? That time is also mentioned here, it is 4 seconds. So here I will take time as 4 seconds. Now students, we have to calculate the angular acceleration for this particle. So I need to calculate what is alpha. So what the equation we are going to use under this situation? So you need not to remember the different equations for different situations. Let us move with v is equals to u plus at, as omega 2 is equals to omega 1 plus alpha t. That just now we have seen. What is omega 1? What is omega 2? So omega 2 here it is 200. That is equals to 100 plus alpha into 4. So what is this? 4 alpha is equals to, this is 200 minus 100. I'm taking this 100 here. So it is 4 alpha is equals to 100. So angular acceleration we are getting as 100 by 4, that is 25, and the units will be radians per square second. Now students, let us move for the next problem in kinematics of rotational motion. So the next problem here, what we have, the angular speed of a motor wheel is increased from 600 rpm to 1200 rpm in 4 seconds. Calculate how many revolutions does the engine make during this time. So you can see clearly what is the initial velocity here. Initial angular velocity omega 1, it is 600 rpm, and final is how much? It is 1200 rpm. 1200 rpm, and the time is also mentioned as t is equals to 4 seconds. 4 seconds, and in this situation we need to calculate how many revolutions does the engine is making here. So in to understand this, what the concept is being asked here, number of, what I can say, the revolutions. How many revolutions does the engine is making for 1 second? We have to calculate. That means in this time, the time is 4 seconds is mentioned. How many revolutions? So for that, first of all, you have to calculate what is the angular displacement. How much is the total angular displacement? But before going for the total angular displacement, हम जब calculate तो करते हैं बेटा, लेकिन उससे पहले थोड़ा सा आप ध्यान दीजिए. Omega 1 is 600 rpm. What is omega? Omega is the angular velocity. And you know the units for angular velocity, it is radians per second. But here the units are mentioned as revolutions per minute. Revolutions per minute or the rotations per minute. So यहाँ पे when the units are not as per the SI unit, पहले तो हम convert करेंगे SI unit के तहत, ठीक है. तो यहाँ पे हम कैसा करेंगे, देखिए, this is 600, I will take it as 600 only. So in order to convert rpm into radians per second, r means revolution, और एक revolution में कितना होता है बेटा, 2 pi होता है, 2 pi angle, और this is revolution के लिए आप लिखेंगे 2 pi divided by, this is per minute, no, this is per minute, means it is 60. Try to understand why what I am multiplying and why I am multiplying. फिर से, rpm is not the unit for angular velocity, radians per second is the unit. So one revolution is how many radians? 2 pi radian. That is one revolution. R stands for revolution, that is 2 pi radian. एक revolution जब घूमता है तो 2 pi angle cover करता है ये. By per minute, per means by, minute means it is 60. So what is the answer we are getting in terms of radians per second? This is 1 times and this is 10 times, so this is 20 pi, and the units will be radians per second. Now let us move for this. This is how much? 1200, and this is also in radians per second. So this is, I want this in radians per second, but the given it is rpm. तो हम यहाँ पे भी हम 2 pi by 60 से मल्टीप्लाई करेंगे बेटा. This is 1 times, this is 20 times, so it will be how much? 40 pi radians per second. So here, first of all, to calculate number of revolutions, we should know what is the total angular displacement. So Here you can see clearly omega 1 is given, omega 2 is given, t is given. अगर हम लीनियर डिस्प्लेसमेंट की जब बात करते हैं तो s इज इक्वल्स टू u प्लस वी बाई टू इंटू टी कैलकुलेट करेंगे. तो यहाँ पे हम क्या यूज करेंगे बेटा, यहाँ पे टोटल एंगुलर डिस्प्लेसमेंट दैट इज ओमेगा 1 प्लस ओमेगा 2 बाई 2 इंटू टी. व्हाट इज ओमेगा 1? दैट इज 20 पाई प्लस 40 pi by 2 into how much? It is 4. As per the question, it is 4. So 1 times, this is 2 times. This is 60 pi into 2, that is 120 pi radians. Total angular displacement, ये हमारे को मिल गया बेटा radians. This is this many radians. But the question is not asked as what is the total angular displacement. So instead of asking total angular displacement, what the question asked is number of revolutions. तो आपको मालूम होना चाहिए एक कंप्लीट रेवोल्यूशन में कितना एंगुलर डिस्प्लेसमेंट होता है. जस्ट नाउ आई सेड वन कंप्लीट रेवोल्यूशन के लिए 2 पाई, आई रिपीट वंस अगेन, 2 पाई इज द एंगुलर डिस्प्लेसमेंट. तो नंबर ऑफ रेवोल्यूशंस अगर हमारे कैलकुलेट करना है, नंबर ऑफ रेवोल्यूशंस इन 4 सेकेंड्स हमारे को कैलकुलेट करना है. नंबर ऑफ रेवोल्यूशंस पूरा, क्योंकि ऑलरेडी हम एंगुलर डिस्प्लेसमेंट किसके लिए करें बेटा, 4 सेकंड्स के लिए करें. तो नंबर ऑफ रेवोल्यूशन भी हमारे को 4 सेकंड के लिए आएगा. सो इट इज व्हाट, 120 पाई एंड हम डिवाइड करेंगे यहाँ पे 2 पाई से. why I am dividing by 2 पाई? the reason here is for each revolution angular displacement is 2 पाई. तो अगर मैं 2 पाई से डिवाइड करता हूं तो number of revolutions I am going to get. So here pi get cancelled and here it is 60. So here I can say 60 is the answer, or 60 is the number of revolutions. Hope you have understood the question along with the solution. One thing students, here what I was saying, or what I always say, don't go along with the, what I can say, the length of the question. Try to understand what the question is and what is being asked. So for this, to understand the question and what is being asked, you should know the concept behind that. आपको concept आपको याद होना है बेटा, concept आपको समझना है. Until and unless you understand the concept, it's very difficult for you to move with the problem. I hope it is clear.